In the Internet addressing architecture, a private network is a network that uses private IP address space, following the standards set by RFC 1918 for Internet Protocol version 4, and RFC 4193 for Internet Protocol version 6. These addresses are commonly used for home, office, and enterprise local area networks, when globally routable addresses are not mandatory, or are not available for the intended network applications. Under IPv4, the private IP address spaces were originally defined in an effort to delay IPv4 address exhaustion, but they are also a feature of IPv6, the next-generation Internet Protocol. These addresses are characterized as private because they are not globally delegated, meaning that they are not allocated to any specific organization, and IP packets addressed with them cannot be transmitted through the public Internet. Anyone may use these addresses without approval from a regional Internet registry. If such a private network needs to connect to the Internet, it must use either a network address translator gateway, or a proxy server. Private IPv4 address spaces. The Internet Engineering Task Force has directed the Internet Assign Numbers Authority to reserve the following IPv4 address ranges for private networks, as published in RFC 1918. Dedicated space for carrier-grade NAT deployments. In April 2012, IANA allocated 100.64.0.0/10 for use in carrier-grade NAT scenarios in RFC 6598. This address block should not be used either on private networks or on the public Internet. It is intended only for use within the internal operations of carrier networks. The size of the address block was selected to be large enough to uniquely number all customer access devices for all of a single operator's points of presence in a large metropolitan area such as the Tokyo metropolitan area. Private IPv6 addresses. The concept of private networks and special address reservation for such networks has been carried over to the next generation of the Internet Protocol, IPv6. The address block FC00/7 has been reserved by IANA as described in RFC 4193. These addresses are called unique local addresses. They are defined as being unicast in character and contain a 40-bit random number and the routing prefix to prevent collisions when two private networks are interconnected. Despite being inherently local in usage, the IPv6 address scope of unique local addresses is global. A former standard proposed the use of so-called site local addresses in the FEC0/10 range, but due to major concerns about scalability and the poor definition of what constitutes a site, its use has been deprecated since September 2004 by RFC 3879. Link local addresses. Another type of private networking uses the link local address range. The validity of link local addresses is limited to a single link. For example, to all computers connected to a switch, or to one wireless network. Hosts on different sides of a bridge are also on the same link, whereas hosts on different sides of a router are on different links. IPv4. In IPv4, link local addresses are codified in RFC 6890 and RFC 3927. Their utility is in self-auto-configuration by network devices when dynamic host configuration protocol services are not available and manual configuration by a network administrator is not desirable. The block 169.254.0.0/16 is reserved for this purpose, with the exception of the first and the last/24 subnets in the range. If a host on an IEEE 802 network cannot obtain a network address via DHCP, an address from 169.254.1.0 to 169.254.254.255 may be assigned pseudo-randomly. The standard prescribes that address collisions must be handled gracefully. IPv6. In IPv6, link local addresses are codified in RFC 4862. Their use is mandatory, and an integral part of the IPv6 standard. The IPv6 addressing architecture sets aside the block FE80/10 for IP address auto-configuration. Common uses. The most common use of private addresses is in residential networks, since most Internet service providers only allocate a single publicly routable IP address to each residential customer, but many homes have more than one computer or other Internet-connected device, such as smartphones. In this situation, a network address translator gateway is usually used to provide Internet connectivity to multiple hosts. Private addresses are also commonly used in corporate networks, which for security reasons, are not connected directly to the Internet. Often a proxy, SOCKS gateway, or similar devices are used to provide restricted Internet access to network internal users. In both cases, private addresses are often seen as enhancing network security for the internal network, since it is difficult for an Internet host to connect directly to an internal system. Misrouting. It is common for packets originating in private address spaces to be misrouted onto the Internet. Private networks often do not properly configure DNS services for addresses used internally and attempt reverse DNS lookups for these addresses, causing extra traffic to the Internet root name servers. The AS112 project attempted to mitigate this load by providing special black hole unicast name servers for private address ranges which only return negative result codes for these queries. Organizational edge routers are usually configured to drop ingress IP traffic for these networks, which can occur either by misconfiguration, or from malicious traffic using a spoofed source address. Less commonly, ISP edge routers drop such egress traffic from customers, which reduces the impact to the Internet of such misconfigured or malicious hosts on the customer's network. Merging private networks. Since the private IPv4 address space is relatively small, many private IPv4 networks use the same address space. This creates a common problem when merging such networks, namely the duplication of addresses on multiple devices. In this case, networks or hosts must be renumbered, often a time-consuming task, or a network address translator must be placed between the networks to masquerade the duplicated addresses. To mitigate this problem for IPv6, RFC 4193 specifies a large unique global ID to be pseudo-randomly generated by each organization using unique global addresses. It is very unlikely that two network addresses generated in this way will be the same. Private use of other reserved addresses. Historically, address blocks other than the private address ranges have been reserved for potential future uses. Some organizations have used them for private networking applications despite official warnings of possible future address collisions. Typically these addresses are not referred to as reserved. IPv4 addresses 240.0.0.0 to 254.255.255.254 are designated for future use and research and development. See also, Heartbeat Network, Intranet, a private Internet, reserved IP addresses, RFC references, RFC 1918 a Euro address allocation for private Internets, RFC 2036 a Euro observations on the use of components of the Class A address space within the Internet, RFC 2050 a Euro Internet Registry IP allocation guidelines, RFC 2101 a Euro IPv4 address behavior today, RFC 2663 a Euro IP network address translator terminology and considerations, RFC 3022 a Euro traditional IP network address translator, RFC 3330 a Euro special use. IPv4 addresses, RFC 5735 a Euro special use IPv4 addresses, RFC 6890 a Euro special purpose IP address registries, RFC 3879 a Euro deprecating site local addresses, RFC 3927 a Euro dynamic configuration of IPv4 link local addresses, RFC 4193 a Euro unique local IPv6 unicast addresses, RFC 6598 a Euro reserved IPv4 prefix for shared address space. Notes. References.